you need to understand something called RDD. Okay, so that is why RDD fundamentals it is written. So RDDs are the basic building blocks of Spark. So first thing you need to understand is that in Spark, your data is represented as something called RDD, right? Any data that you have, if you want to process in Spark, the first step you do is that you create something called an RDD. RDD stands for Resilient Distributed Dataset. It is like a variable or a pointer, you can say, right? So these slides will give you some idea about RDD. I will also practically show what is an RDD, right? So, just look at this picture. This picture is very good in understanding how Spark is working, right? So I have 4 blocks of data in Hadoop. So that is what is represented there. HDFS, right? So 4 blocks of data is there, right? And I want to process them. Now that is one file. Even though it is divided into 4 blocks, it is one single file I want to process. And what is this data? It's some text data. Imagine each block has like this: error, then a timestamp and a message. Again, warning, some timestamp and a message. Some log file, imagine, right? 4 blocks of data. So we are assuming they are on 4 data nodes and you want to process them. Now from here onwards, it is going to confuse you. Okay, so I'm saying in advance, you will get confused, okay, but don't worry. So where is your original data in hard disk, right? As blocks in HDFS. So that you have to keep it in your mind. Now, I have already written a program, imagine, to process the data, right? In the program, the first step I need to do is to create an RDD, okay? So I have to say that create an RDD. An RDD is like a variable, you can say, or a pointer. So here, the name of my RDD is called log lines RDD. You can call it Raghu if you want. I just say create, hey Spark, create something called log lines RDD by reading the data from this file. You can give the location, where is the file. And if I run this, what is going to happen? And imagine in this case, I have asked for 4 executors. In my Spark program, I said, I want 4 executors for some reason. So what will happen in each data node, one executor will be launched in ideal situation, right? And I have one block on each data node. And I say, hey Spark, create an RDD called loglines RDD for me. And if I hit enter, all this data will be copied into the RAM or the main memory. Because RDDs represent your data in memory, assuming RAM is available, ideal condition. So if I redraw this picture, this is actually a Databricks picture, right? But if I redraw this picture, now don't think that always the file is in Hadoop, right? In my typical example, I have the file in Hadoop. But there is one small thing here. Let's say you have 6 nodes in Hadoop cluster. 1, 2, 3, 4, 5, 6. That is the same architecture. And block 1, 2, 3, 4. Now the big question. You want 4 executors. Which machines will launch the executor? Yarn. Yarn has no data locality awareness, right? Yarn doesn't know where is your data, right? In MapReduce, data locality is there because your blocks are residing here. Let's say your blocks are here, right? So these are the 4 blocks. I write a MapReduce program. What is going to happen? In my MapReduce framework, it is written that, okay, I need to have 4 mappers. One more very important point you need to remember. In MapReduce, if I'm processing the same data, 4 JVMs will get launched. Correct? One here, one here, one here, one here. And this will copy here, this will copy here, this will copy here, this will copy here. That is how your mapper runs. Because can you process 4 blocks using one mapper? Not possible. You will have number of mappers equal to number of blocks or number of input splits, we say, right? Ideally, you can say number of mappers equal to 1, but then what is going to happen? This block will process, this will go, then the next block will come and it will process. This is your yarn container in MapReduce. So when yarn is launching containers for your mapper, Ideally, how it launches is that it will launch one container for each block, right? And your block size is fixed at 128 MB, right? So in yarn settings, you will say that my container size is 1 GB. I want 1 GB container, right? And what will happen? 1 GB, 1 GB, 1 GB, 1 GB, 4 containers will be used. It is very rare that manually you mention number of mappers. You can't ideally do that because that will affect your performance. And also, if you are launching one container only, you can't resize it. So this is like a 1 GB container. And I have never seen anybody using static mappers. In 99.99% of the programs, you will never touch the number of mappers. You will just say, I want to process it. And ideally, if you have, let's say, ideal situation saying 4 blocks, you will launch 4 mappers, right? Each block will copy to one mapper, your mapping phase is over. Then reduce or whatever. Spark is different. In Spark, one of the core principles is that you can control how many containers you want and what is their size also. So I can say I want 4 containers in Spark. So now we are talking about Spark, okay? In Spark, I can say I want either a single container, that's what I'm saying, executor. I can say I want only one executor and this guy has 8 GB RAM. So it will launch only one. And these 4 blocks can come inside this and get processed. Fine. Or I can say I don't want one executor. Probably I want to leverage parallelism. I want, let's say, 4 executors. But the point is, when you say you want 4 executors, there is no guarantee these 4 will come here. It can be here, 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 here also. In that case, this block need to be copied into the RAM of this machine. So initially there may be a delay to get the data to that RAM, then it will be same. There are 2 things. There is something called Spark dynamic execution allocation. You can enable it and disable it. If you enable it, what will happen? It will launch 8, kill 7. Only 1 will remain. If you disable it, it will keep 8 as it is. So there is a property called set spark dot dynamic execution enable or disable. That is to yarn. So you are telling yarn, I want 8 executors, but don't kill everybody. I may use it or may not use it. So it will keep it for you. If you enable it, that is where it will kill. You are saying that if it is not getting used, just kill them. I don't want them. So if your data size is small, it will kill them. Remember, you can actually see in the Spark UI 5 of them coming up and then remaining them will getting deleted automatically. You can do that, right? But coming back to RDDs and our discussion, I am saying that in that example, you have 4 blocks of data. So that is these 4 blocks. My Hadoop cluster is, let's say, 6 nodes. And you want to read this data and process it. So what you say, I want to create an RDD. The name of the RDD is called log lines RDD or whatever. RDD is just like a pointer, okay? And when you do that, when that code runs, what is going to happen is that you ask for 4 executors also. And let's assume the executors are launched here. So there is an executor here, okay? There is one more guy here, one more guy here, and one more guy here. So these blocks will be copied to here. So now where is your data? Your data is residing inside the RAM of 4 machines or 4 executors. This is called an RDD. Because otherwise, how do you call it is your data? You need some way to mention like a variable. So that is called your RDD. So now once the data is available in the RAM, let's say now the data is there, you have a representation to your data. So this entire log file is now called log lines RDD. Also in Spark, there is something called partitions, meaning right now your data is lying as 4 blocks. So we say that this is a 4 partition RDD. So normally when you're reading from Hadoop, you will have blocks. Each block will become a partition. What if you're not reading from Hadoop? Let's say I'm reading from my local PC. I can mention how many partitions I need for the data. Say on my Windows laptop, okay, I have a 1 GB file. If I simply read it, it will come as a single 1 GB partition. Okay. If I want, I can say that, hey, this is in my Windows laptop. Okay. I can say that, hey, Spark, read this 1 GB, but create 4 partitions for me on this. What is the advantage? Each partition can go to an executor. An executor will process a partition, not a file. So always your data has to be partitioned. The more partitions you have, the more parallelism you will get. Or let's say you're reading from Cassandra. a typical example. Cassandra is a NoSQL database. Cassandra doesn't have blocks or anything. Blocks are on Hadoop. So if I get the data from Cassandra, I read a table, I will get 1 million rows, right? 1 million rows, I cannot give it to an executor, right? Then the processing will be very slow. So what I will do, I have to have an idea about my data. Let's say 1 million data is 1 GB or something. I will say that when I'm creating an RDD, I can say that take this data from Cassandra and divide it into 4 partitions. Each partition will go to an executor. An executor can manage more than 1 partition also. Minimum 1 partition it should get. Depending, so let's say I have an executor with 20 GB memory. So let's say a partition size is 1 GB. It can manage 20 partitions. So data locality is not 100% guaranteed when you launch an executor. 100% it is not guaranteed. So is this clear? Because you have to figure out the number of executors. Okay, first thing, that depends on what is the size of your data. So in Hadoop, normally this is not required, because in Hadoop what happens, by default a block is a partition, right? But again that will make sense, because what is the block size in Hadoop? 128 MB. 128 MB is the block size, right? So I have a file with that is divided into 10 blocks. So total size of the file is this MB, that is 1.2 GB. I want to process 1.2 GB file. Now the question is that how many executors I need. That depends on your cluster configuration. I can even process this in a single executor. I can ask, hey Yarn, give me 1 executor, 2 GB RAM or 3 GB RAM, just a safe side I'm saying. So Yarn will launch 1 executor, let's say 3 GB RAM, okay? And this has 10 partitions. This file has 10 partitions, 10 blocks. All 10 partitions will come in that single, container, get processed. So this executor, right? So this executor you are launching, okay? So you can ask how many executors you want. So the more partitions you have, more processing speed you will get. This same example if you take, so I have 4 partitions, right? 4 executors I launched, and each is getting loaded into 1 partition. This will be faster. I can also launch a single executor here, copy all this 4 here. It may not be so fast. And another very important point, so these are all related to resource management, but you should also understand this stuff, right? An executor is a container, right? A JVM. 1 processor core is required to manage 1 container. Meaning, if this is a dual core machine, how many maximum executors you can launch? 2. If you ask for 8 executors, what will happen? It doesn't work. So an executor is a JVM. To manage a JVM, JVM has RAM and CPU. RAM, you can say, I want 8 GB RAM, 10 GB RAM, fine. But within that, to manage, ideally, for a single JVM, 1 processor core will be allocated. Minimum 1 processor core, right? But again the question, if I have 16 GB RAM, 16 GB RAM for a container, that will have lot of partitions inside that. Maybe 1 CPU core is enough to run all of them. Depends on what is the processing power of your machine. But you have to keep all these things when you're launching a cluster. Performance side I'm saying. So to put it short, ideally you don't have to do these many things. When you're launching a Spark program, you should know the size of your data and how it should be chunked. So the idea is, if the number of partitions are more, so let's say I have a file, whatever the size may be, X, size is X, right? If the number of partitions are more, that means the number of splits are more, ideally. So I'm saying that I want 10 partitions. So I get 10 partitions. Now, if each partition can be inside an executor, 10 executors can process that data. So parallelism you get. But if it is less, let's say I want only 2 partitions, then they are in 2 executors, then 2 executors are, so ideally your this is less, what you say, processing. So the more partitions you have, the more processing power you can get. So if you are loading, let's say, a text file, right? So if I am loading a text file, I can say that create an RDD, number of partition 5. So what, it will equally split that text file into 5 and then give it to one executor. But the point is, you need 5 executors to process it. So if you go to Yarn, Yarn will say, I don't have enough resource, I'll give you only 2 executor. So 2 executor will get 5 partition. One guy will get 2, another will get 3. So, and each executor is having 1 CPU core, right? So it will be a bit slow. So if you have enough resources, parallelism works actually better. Ideally, in a Hadoop world, your data is divided into blocks. Each block is in a data node, and that is 1 partition. So if I'm reading a file from Hadoop, if that file has, let's say, 20 blocks, 20 partitions will be created. But now when I get 20 partition, the question is that should I load them into 20 executors? Can I get 20 executors? Maybe not. I will have only 10 executors maybe. Also, in that executor, how much RAM you have, how much CPU power you have. But these are not just admin topics. The developer has to make a choice here. If you have a file, this is your file, right? This is your file. And this file is divided into 10 blocks in Hadoop. Okay? So I have what? I won't exactly write it, but let's say 1, 2, 3, 4, 5, 6, up to 10 blocks you have. Okay? Now to answer your question, right? When I read the data into Spark, it will automatically do something called partitioning. And each block will become 1 partition by default. And you cannot change it. Okay? By default, it is 1. And most of the cases, we keep it. But what you can do, so I get, this is 1 block. This is 1 block. So all this is red. So this is my partition 1, partition 2, partition 3, right? This is what? Partition 4. And I have partition 10. Similar to input splits. So you have 10 partition. Now you want to process it. That is where the speed and all matters, right? To process it, what you need? You need RAM, you need CPU power, right? So where this partition will go, this is hard disk. Blocks are where? This is hard disk. Blocks are in your hard disk. When I say I create a partition, partition is in RAM. It won't just sit in the RAM. It has to be inside an executor or a JVM, right? That is where the data should come. Then only the processing should start, right? So then you can decide, I have 10 partitions. Okay, how many executors I need? Can I ask for 10 executors? Yes, you can do. You can say, I want 10 executors. Okay, so you will get what? Executor 1, and here you will get executor 10. And each partition will go to an executor. Partitions always go to executor. So this P1 will go to this executor. Now this executor, I have asked for 1 GB RAM for this executor. I also have 1 processor core. That means this partition can be managed by this executor. Same, your P10 will go here. Okay, this executor also have 1 processor and 1 GB RAM. But the point is, your yarn should allow you to give you 10 these things. The same thing I can do in another way. I ask for only 2 executors. Example, okay? I ask for 2 executors. This executor has 5 GB. This executor also have 5 GB. This has 1 processor core. This has 1 processor core. And P1, P2, P3 up to P5 will come here. P6, P7, P10 will come here. Logically, Spark actually segregate them. Partitioning is just to understand that you have different splits on the data. But now if you write a program, so let's say I wrote a program, I say filter the data. So my driver is here, right? This is what? My driver. In my driver, I said filter the data. Where is the data? In partition. So this filter is your logic. This logic will be pushed to this executor, and this filter will apply here, 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 here. Who will apply? This processor and RAM together, right? So 1 processor core I have. Using that 1 processor core, can I parallelly run this? Probably. I have multi-threading and all. I can parallelly process this much amount of data. Good. Otherwise, one by one it will process. It will take some time. Depends on how much you have. Yes, your processor core you can increase. You can even say I want 4 cores for the container. When you are launching this executor, I said 1 core by default, right? I can also say, hey, yarn, give me my executor. Each executor requires 4 core. But then the problem is, if this is a quad core data node, only one executor can be launched because you already took 4 cores. If you ask one more, you will not get, right? If this is a quad core data node, if you launch one executor, you cannot launch another executor. Already you have taken 4 cores. So in production, how we do it is that once we design our application, we look at the data, from where the data is coming. Will it already come partitioned, or you have to partition? Because if you're reading from Hadoop, it already is partitioned, like blocks and all. But if you're reading from Cassandra, Cassandra doesn't by default partition the data. So you get like one big chunk. So while reading, we decide, should we partition? Yes, we partition. How many? 10. So 10 means what will be the size? This much. So how many executors you need? So then you go to your admin and say that, can I launch a Spark job with this many? Will I be getting? He will say, yes, you will be getting. Then you launch them.